When buying a bead mill, most customers firstly focus on factors such as price, capacity, and delivery time. However, after the equipment enters production, problems may occur, including failure to achieve the target particle size, excessive temperature rise during operation, actual capacity falling below expectations, or even deterioration of final material performance in most cases. The problem isn't the equipment itself, it's that the bead mill wasn't properly selected. So, how should you choose the right bead mill? There are 4 key factors. 1. How to choose the rotor structure. The first thing to consider is the rotor structure. The 2 main types are the turbine rotor and the pin rotor. The turbine rotor optimizes the movement of the grinding media, allowing the zirconia beads to circulate in a stable and efficient pattern. It provides more uniform grinding performance and better preservation of material structure. It is suitable for applications requiring narrow particle size distribution and excellent material performance. The pin rotor uses densely arranged pins to increase impact and shear inside the grinding chamber. It quickly breaks up agglomerates and delivers higher grinding efficiency. It is better suited for high-hardness materials, heavily agglomerated materials, and applications requiring high energy input. Neither rotor is universally better. The right choice depends on material viscosity, hardness, target particle size, and production requirements. 2. How to choose the separation system. During operation, the ground material must be effectively separated from the zirconia beads. The separation system directly affects continuous operation. The 2 most common methods are screen separation and centrifugal separation. Screen separation uses a precision screen to allow the slurry to pass while retaining the grinding media. Common designs include ceramic disc screens and wedge wire screens. It is a mature technology with a wide range of applications. Centrifugal separation uses high-speed centrifugal force to dynamically separate the material from the grinding media. It reduces the risk of blockage and is more suitable for high solid content slurries, high flow rates, and continuous production. The right separation method should be selected based on slurry viscosity, circulation flow rate, and target particle size. 3. Are smaller zirconia beads always better? Many customers believe that the smaller the zirconia beads always provide better grinding performance. In fact, that's not always true. Smaller beads provide more contact points per unit volume, making them ideal for nanoscale grinding. However, they also place higher demands on the machine's separation system and process stability. Therefore, zirconia bead size should be selected based on the target particle size, material hardness, slurry viscosity, and equipment design. Smaller beads are preferred for fine grinding, while larger beads provide stronger impact during coarse grinding. 4. How to choose the grinding chamber material. Common grinding chamber materials include zirconia ceramic, high wear resistance, and low contamination, ideal for high-purity applications such as battery materials and MLCC. Silicon carbide, excellent wear resistance, corrosion resistance, and heat dissipation. Silicon nitride, high mechanical strength and excellent temperature resistance. Polyurethane, good wear resistance and elasticity, suitable for certain special material systems. So, when choosing a bead mill, don't focus only on the model or the price. The right bead mill should be selected by matching the material properties, target particle size, rotor structure, separation system, zirconia bead size, and grinding chamber material. With over 20 years of experience in grinding and dispersion technology, Boyee provides complete grinding solutions from process validation to mass production for new energy battery materials, sodium-ion battery cathode and anode materials, inks and coatings, electronic ceramics, advanced materials, and more.